everybody. I'm Rasmus.
And I'm Nils.
And we're both working for Atlas Copco Gas and Process in Cologne. And today we are out with you here at the River Rhine. And there's something more than just a beautiful background with this river. We will tell you later a bit more about this. For the moment, let's speak first about our role in this company. And I'm working as a market segment manager for new energy systems, which covers geothermal power, energy storage and large industrial heat pumps. What about you, Nils?
I'm an application engineer at Atlas Copco, which means that I'm responsible for creating the technical proposals for our customers, especially in the new energy market.
Yeah, and now we will tell you about our role in the new energy market and how our technology can contribute to a low carbon society.
You previously mentioned the river. What is the connection between the river and our technology?
Yeah, of course, while it's a beautiful background here, there's something more I said already about this river. And that is the fact that this river just carries huge amounts of water. And water is a great heat carrier. And therefore it offers us the possibility to use this heat even in the deepest winter to heat industrial processes. This sounds maybe a bit strange if I say even when the air temperature is dropping to zero, you still can take heat out of this river. But it's possible with the right technology.
Okay, so especially in the winter, there's a pretty high demand of heat in the industry and also for district heating. But at this time of the year, the river is really cold. You mentioned 3 degrees Celsius. How is it possible to shift that low temperature up to useful temperature for the industry, for processes?
I mean, in the end, the system we are operating with is like a larger brother or sister of the fridge you have at home. And in the fridge, there are always some components. There's a compressor, there are evaporator and condensers. And in the system, there is a gas filled in. And in the most fridges, there's something like the gas that is in a fire lighter. But of course, other gases are possible. And in the inside of the fridge, this gas is evaporating. The compressor brings it up to a higher pressure, and there it can condense. And this step chain, evaporation, compression, condensation, increases the temperature of the energy that is taken from the inside and brought to the outside. So by utilizing a system that compresses gas that was formerly evaporated and condensed on higher level, you can bring up the temperature from ice cold temperatures, like the river water has here, to useful levels of temperature that you can use in the industry and in district heating.
Okay, so you mentioned the fridge and you compared it with our technology. What is the difference? You won't put hundreds of refrigerators in the industry. What is the difference between a fridge and our heat pump?
Of course, this I picture it a bit funny if you enter an industrial facility and you see like thousands of fridges standing there. So of course our technology would look a bit different than the fridge at your home. It is more like, it looks like a chemical plant. The centerpiece of it, however, is still a compressor. In this case, it is not a compressor from your fridge, it is an industrial turbo compressor. Those we are making here in Cologne in our facility. And those compressors, they are using in the end the same principle. They are evaporating a gas, compressing it to a higher level, and then rejecting the heat. So in the end, we take the fridge and build the bigger brother or sister of it.
Rasmus, in which industries can industrial heat pumps be used?
Yeah, well, it's pretty straightforward to say. Everywhere in the industry where you need large power quantities and where the temperature level is not higher than, let's say, 300 degrees Celsius, there you can use industrial heat pumps. You have to keep in mind, of course, if you need the chemical reaction of an open flame, then of course you cannot use a heat pump. Like when you want to melt iron ore or you want to burn bricks, then of course you need the chemical reaction of a flame. But when you, for instance, want to heat up something for food processing, like making salt or sugar, or you want to distillate substances in chemical factories, then of course you don't need temperatures that high. So everywhere where you can get away with temperatures below 300 degrees, a heat pump can be used. And the cool thing is, in most of these processes, after the heat has been used once, it's thrown away. And the heat pump can be used instead of a cooling tower to recover this heat and bring it back to useful heat levels, temperature levels where you can utilize it. So it's literally closing the loop for a circular economy.